Assalamualaikum and hi, my name is Syafiqah Binti Mazni, and in this video I am going to present my final year project with the title of Effectiveness of Antibacterial Pepper from Solanum tuberosum, Zingiber officinale and Citrus sinensis pills. Antibacterial pepper is made up of antibacterial agents which can inhibit the growth of bacteria, because bacteria can cause a lot of diseases such as pneumocystis, which is commonly found in immunocompromised people and can lead to pneumonia. And antibacterial pepper may be made by combining new or recycled pepper with antibacterial compounds derived from vegetable and fruit peels. Alkaloids, saponins, tannins, flavonoids, and steroids are phytochemical compounds that are physiologically active and hence substantially responsible for plants' antibacterial properties. The problem statements of this project is peels, pips, and fibers of fruit are not fully utilized as a resource for any commercial purpose, and as a result, they become a source of pollution sensitive to microbial decomposition, resulting in odors and other environmental dangers. The use of pepper is preferable to the use of plastic, particularly for food packaging, due to the properties of plastic, which include its inability to decompose quickly and can take years. The significances of study are: antibacterial pepper can be used to preserve essential peppers against bacterial infection and growth. Next, antibacterial pepper as a food wrapper, which then will serve as extra protection for the food wrapped in it. Other than that, the production of antibacterial pepper can be made by using recycled pepper, which pepper recycling aids in the preservation of forests, the protection of the ozone layer, and the reduction of pollution. Lastly, utilizing fruit and vegetable waste for good use also contributes to reducing the accumulation of solid waste, which can lead to a lot of negative effects on the environment. There are two objectives of this study, which is first, to formulate the production of antibacterial pepper using Solanum tuberosum, Zingiber officinale, and Citrus sinensis pills, and second, to determine the effectiveness of antibacterial pepper from Solanum tuberosum, Zingiber officinale, and Citrus sinensis pills against Escherichia coli and Bacillus licheniformis using this diffusion assay. And this is the research questions of this study. In this chapter, we are going to focus on literature review of the pills and its bioactive compounds that can be found in the peels of a ginger, potato, and orange. And also we are going to focus on antibacterial and antibacterial pepper. In this chapter, I am going to talk about methodology and material. And this is the experimental design of peel extract, which is we are going to extract the compounds, the bioactive compounds of the pills. And in this experiment, the solution that we use is 95% of ethanol, and the method that we use to extract the pills is hot plating. As for experimental design of antibacterial pepper, we use grounded pills that has been formed into a powder together with A4 pepper, and both experimental design we test the antibacterial test using this diffusion assay. In this chapter, we are going to discuss on the result. 4.1 is about the antibacterial peppers were produced for every peel, which are orange, potato, and ginger, to test on bacterial strain of E. coli and B. licheniformis. The production of antibacterial pepper was to observe the powder of the desired peels inhibit the growth of the antibacterial strain by using this diffusion assay. The two figures below, we can see it is the production of antibacterial pepper before and after drying process. As for 4.2, the table below shows the potential of orange, potato, and ginger peels extracts against E. coli and B. licheniformis presented in mean plus minus standard deviation by using one-way ANOVA. The data summarized from the table show that there was no inhibition zone for all both isolated bacteria, E. coli and B. licheniformis that were tested with peel extracts of orange, potato and ginger. As for positive control, ampicillin exhibited inhibition zones on all three plates of both bacterial strain, E. coli and B. licheniformis, which were 15.67 plus minus 2.08 mm and 5.67 plus minus 0.58 mm respectively by using one-way ANOVA test. One-way ANOVA was the statistical test applied in this research and the p-value was set at 0.05. As for the result on antibacterial paper, this diffusion assay was performed to determine the antibacterial susceptibility profile of D and identify bacterial strain E. coli and B. licheniformis. Unfortunately, as we can see from the table, there was no inhibition zone for each antibacterial paper made from the peels of orange, potato and ginger for both bacterial strain E. coli and B. licheniformis. Furthermore, ampicillin also did not show any inhibition zone on both bacterial strain. Based on the table, it can be concluded that the bacterial strains were not inhibited by the antibacterial peppers made from the peels and ampicillin after 24 hours of incubating at 37 degrees Celsius. No inhibition zone of peel extracts and antibacterial pepper production of peels can be occur due to many factors that can be detected. One of the factors influencing antibacterial action is bacterial condition. When exposed to antibiotics, the bacterial phenotypes change, including sensitivity, resistance, tolerance, and persistence. Other than that, it might be an inoculum effect. Bacteria may show signs of susceptibility when exposed to a typical dose of inoculum, which is 10 to the power of 5 CFU over ml, but resistance when exposed to a higher dose. Furthermore, it can be presumed that the method used to extract the antibacterial compounds from the peels powder was not suitable for this study. As in this study used hot plating method to produce the solid extract, the compound that contain antibacterial agents might be damaged because of the temperature used. Another possibility is the antibacterial properties might be failed to be extracted by using the extraction method, or antibacterial activity was unstable and degraded before the susceptibility test was performed on the bacterial strain. In conclusion, the production of antibacterial peppers made from the peels of orange, potato and ginger cannot be proved the effectiveness of the peppers against Escherichia coli and Bacillus licheniformis through Kirby-Bauer technique, this diffusion assay. There was no inhibition zone on all three MHA plates of each bacterial strain, including for positive control, ampicillin. The value of p-value was less than 0.05 for both E. coli and B. licheniformis. Thus, it can be concluded that the null hypothesis, which was the peels of orange, potato and ginger can inhibit the growth of the bacterial strain, was rejected. These are a few recommendations that can be made for future study, which are: first, use other extraction method of extracting compounds of interest, such as maceration method, in order to avoid from damaging the compounds. Other than that, use a suitable apparatus to load the extracts, such as blend disc, not filter paper. This is because blend disc is more thick and can load more extract rather than filter paper. And lastly, use a suitable machine to handle bacteria or fungi such as laminar flow. This is because laminar flow can help from foreign substance to contaminate your plates or bacterial strain.